Good morning, everyone. We are Group 8, and today we're going to present our group assignment. So in this presentation, we'll be presenting our introduction, floor plan layout, justification of topology, IP addressing scheme, and conclusion. So my name is Phoebe, and I'm the group leader of Group 8. So I'll pass to my teammate, Daryl, which started from our introduction.
My name is Daryl, and my student ID is 0362920. This is our introduction part. The objective of this project is to design and implement a local area network for a mid-size two-tier company using PowerE and SP's relation 2. This design integrates both wired and wireless networking principles, focusing on configuring routers and switches, developing effective IP addressing schemes, and optimizing network performance through subnets. The first floor supports administrative activities, staff workstations, servers, and restrict guest access, while the second floor focuses on customer-facing business operations with enhanced wireless connectivity. The goal is to create a scalable network solution that ensures availability, secure data transfer, and ease of management for clients and employees. Now I will pass to my teammates.
Hi everyone, my name is CB and my student ID is 0363879. So this is the floor plan for our company building, and this is the first floor plan. So you can see that here we have this data server room, which contains 5 data servers and 1 switch and 1 wireless access point, which is a Wi-Fi, and the main router that connects to the ISP and will connect to the main switches. The main switch in the corner room, which we call it as the room 1, and the main switch functions to connect to all switches in both floors. And we have 2 printers in the room 1 with another Wi-Fi access point. So this is the basic layout for floor 1, and we'll be moving on to floor 2. So floor 1 is just our data server. 4 basically contains all data, so not much clients will access to the wireless access point, but the wireless access point is located to supplies around 10 additional for clients to access, and also to make sure that everything in first floor works well. So now we'll move to floor 2, which we divided it into 5 main components, which is the marketing and sales department, operation department, design department, R&D department, meeting information technology, and computer department. So in this room, we allocated 5 to 7 computers as a wide connection for the employees to use. And in the marketing and sales department, we have allocated 1 printer here, and also a switch here. The switch will be connecting the marketing and sales department and the R&D department, which we will be showing later in our topology. And the other switch, we have located it in the operations department, which will connect the rest of the rooms. And we have also put the Wi-Fi access point in the marketing and sales department, which is at the left side of the floor, and another one in the information technology and computer department, which is for the right side of the floor. So we make sure that the whole floor can have a smooth wireless connection. And we also put design to have a washroom, break room, and meeting room for the employees to take a bath and everything to fulfill their needs, and a CE room at the right below corner here. Yeah. So this is the justification of the floor plan, which is the explanation. So now I'll be moving to the number of hosts on first floor and second floor. So in first floor, we have 2 wireless connection, which is the Wi-Fi access point, and we have 3 wired connection, which is the printers and the router, and we have 5 data servers with 1 main switch and 2 switches. And in second floor, we have 2 wireless connection and 32 wired connection, which included the printers and the computers and 2 switches. So the total host on both floors is 49. So now I'll pass it to my teammate to explain the following justification of topology.
My name is Ranjin, and my student ID is 0386872, and this is the topology diagram of the company building. And this company building is divided into 2 floors. On the right is the first floor, and the left is the second floor. All the terminals are distributed in 8 rooms in this company building, and each floor has 2 branch switches, and all the terminals need to connect to these 4 branch switches. These 4 branch switches need to connect to the main switch on the first floor, and the main switch needs to connect the router on the first floor, which is provided by the ISP. And this is the network diagram of the company building.
Hi, my name is Mutao, and my student ID is 0368794. Which will start and the 3 topologies to connect devices on the first and second floors. The main switch on the first floor acts as a route. It's connecting to secondary switches on both floors. Each department on the second floor and the rooms on the first floor have device connected to central switches. In 3 topology, nodes connect hierarchically operating scalabilities, better organizations, and efficient network management. This structure simplifies traveling routing and helps quickly locate and resolve issues. In star topology, each device connects independently to a central switch, ensuring individual device failures don't impact the network and allowing easy addition or removal of devices. Combining these topologies, it provides a balanced network scalabilities and simplicity. The hierarchical structure enhances security by centralizing access controls and monitoring at critical points.
Hi, my name is William Dr. and my student ID is 0362692, and now I will explain the IP addressing schema part. In our network consists of 1 router, 1 main switch, device on 2 floors, and separate department on the floor and front floor. So in floor 1, floor 1 contains a printer and data server, while floor 2 is divided into 4 department and 1 CR room, each connected to 2 switches, linking back to the main switch. The IP address schema for our network is based on the IP range 192.168.10, with the standard mask 255.255.255.0, and the default gateway set to 192.168.1.1, which is the router IP address. The router is assigned the IP address 192.168.1.1, which you can see in this table, serving as the default gateway I just mentioned just now, and the main switch connects all floor switches and devices. He assigned the IP address 192.168.1.2. Next, move on to floor 1. On floor 1, the printer and the data server is assigned the IP address is for 192.168.122.20, which is in the room 1 on the floor 1. And then let's go to the floor 2. In floor 2, switch 3 is assigned the IP address 192.168.1.22. Switch 4 is assigned 192.168.1.1.5. So on the floor 2, we have 2 switches, which in the marketing and sales department and operation department. We can see in the table. Okay, switch and the 4th department and 1 CEO room is from 192.168.123 to 57. So based on our IP addressing schema part, our IP schema ensure consistency and avoid conflict by assigning unique IP address with a single range, create a hierarchical structure with the main switch connecting to flow switch allow for clear traffic segmentation and security. And is designed for scalability and performance with limited broadcast domain. So in our summary, our IP schema provide a well-structured, efficient, and scalable network that meet our current and future needs while maintaining high performance and security. So this is our IP address network diagram, so it will be more clearly and straightforward. So you can show in this table based on this IP address schema part. So next, our okay. So I'll pass to my teammate to explain the conclusion. Thank you.
In conclusion, the proposed network design effectively links the company's administrative and customer-facing needs across the two tiers. Using Huawei ENSP simulation tool, we develop a robust network topology with wired and wireless connections, efficient IP addressing, and proper subnet segmentation. This design guarantees reliable access to network resources, security, and manageability. Our research and simulation validate the approach viability, providing a strong foundation for real deployment. The accompanying report and presentation detail the design approach, reasoning, and outcomes, enabling the technology team to construct a network infrastructure that supports the company's operational goals and future growth. Now I will pass it to my teammates to demonstrate the DNSP. Thank you.
So now we are going to demonstrate how we link all the connection between the computers and the printers and the servers. So before that, we will need to select all the devices. So by clicking the arrow, and then we will pull a big rectangle, which covers all the devices. Yeah, and we'll click the start device. So now the device is starting. Just take a while. Okay. So now all the devices have started. So now we will start to start the router first and connect to the main switch so that we can connect the rest of the connection. So by starting it, I will double click the router. So the router is still in the user view. So before we do all of the connection, we will need to change into system view. So I'll be typing the system view down. Sorry, it's a bit lagging. And now it's already in the system view. So next we will need to display the interface brief. So now we can see there's a list of this interface that we've used, which is the Ethernet, the Gigabyte Ethernet, and the Thread etc. So the only one we will be picking is the Gigabyte Ethernet, which has the up and down protocol, and the up physical one. So I'll be typing integer space Gigabyte Ethernet 0/0/0. Yeah, and enter. So now we already start the router. It will show the command that we started the router, and after we start this router, we can. So now we need to link to the IP address of the main switches. So I'll be typing the IP address and also the subnet mask of the that is used by the main switches. Enter. So now you can see that it's already connected and everything has started. We can now link the connection from the computers to the server first, which I'll be showing the first connection. So now I'll talk about the first connection, which is from the computer to the data server. So I'll choose 3C7, and now I'll need to assign the IP address that we've designed in our IP addressing scheme. So the IP address of this is 192.168.1.31. So the subnet mask is the same 255.255.0, and the default gateway is 192.168.1 and 1. So I'll apply it. Now I'll close it. So I'll lead to one of the server, which is just server 2, so which is 192.168.1 and 30 that I've allocated it. So 192.168.1 and 1. So subnet mask is already connected to the main switch. So now I'll just go to the command pad to link it together by playing the IP address 192.168.1.13. So now you can see that after we claim, so everything is successfully. So 5 packets transmitted, 5 packets received, none of the packets lost. So the average round trip minute is the 46.71 milliseconds. Yeah. So now I'll pass it to my teammate to explain the rest of the connection.
We'll continue to demonstrate another part. So let's go to choose another PC because now we want to pin PC to the PC. So let's choose PC. Okay, we choose the PC25, but the IP is double free. Okay, so we assign the IP address. Okay, PC25, the IP address 192.168.1 and 50. Move on to the subnet mask, also the same order, also 255.255.0, and the default gateway is 192.168.1 and 1. Because we only the one router, so the default gateway is also the same. So just apply it. Again, and go back to the PC6 for ping. So we go to PC6 and by typing ping and the IP address that we assign to the PC25. Yeah, 50. Okay, we press enter. So we saw that we already print successfully by this information. Yeah, so we go to the another part. So we just choose a second floor printer, print the PC to the printer first on the second floor. So we choose the second floor printer, which is the printer 3 at the marketing and sales department. We also assign the IP address first. So we find the IP address for this is 162.168.1. Sorry, it's 192.168. Sorry, but 1 and 23. And the default gateway also the same. And the default gateway 162.168.1 and 1. And the subnet mask already assigned 1. Yeah, 1. And print save. So go back to PC6 and ping to the printer, and by typing ping and the IP address for the printer 168.1 and 23. Okay, press enter. So we also can see for the result that comes from the comment that we also print successfully. We also can see the result from training and measurement 0 adding 47. So we move on to the last one. We print the pieces to the first floor printer. So also assign the IP address was 162.168.1 and 19. And the default gateway also the same 192.168.1. The subnet also the same 255.255.0 and go back to the PC6 and ping. And 93, yeah. And I think, sorry, so press the enter also can see from the result. We also successfully print. So this is our demonstration part. Thank you.